Alright guys, would be following 4 numericals on moment of inertia. Please understand those numericals well, because that would eradicate all the doubts that you have about moment of inertia. Alright, whether it be disk, sphere or whatever. Alright, so follow it and I hope would be helpful. Hi guys, this is a sum. Fan is rotating at 90 rpm. Rotations per minute, 90 rotations per minute. It is then switched off. It stops after 21 revolutions. 21, 1, 2, 3, 4, 5, 6, like that, 21 revolutions. Calculate time taken by it to stop, assuming that friction torque is constant. What do you mean by friction torque is constant? There are ball bearing and all those things which are also applying opposite force. Fan is moving this way, the frictional force is in the opposite direction. So we are assuming that frictional torque to be constant. Now frictional force means it's two forces. I told you torque is what? Torque is two equivalent and opposite forces. Two non-collinear equivalent and opposite forces acting on fan. Now if fan is moving this way, if the fan is moving this way, then this torque would be in the opposite direction, and these torque would be all going to ball bearing and all those things which we put it into the rotator. Alright, okay, fine. So that's the explanation about the sum. Now let's try and understand revolution. Alright, one revolution corresponds to 2 pi radian. Radian is what? 180 degree. So we all know one revolution which is there, that is what is 360 degree, right? And that is 2 pi. So theta is 2 pi. The 21 revolutions, so how many degrees has it covered? It has done 21 revolutions. So obviously multiply it with 21 into 360. So those many degrees it has covered, right? So it becomes 2 pi into 21, that is 42 pi. That's our theta, the angle covered by a fan before it stops. Alright, so I switched off. Let's see the situation now. The fan is moving. Alright, then I switch it off. When I switch it off, there's no power going in there, but it's taking some time to stop. So how much? It's not about the time, how much? So it's revolving. So some revolutions are there before the fan stops. Alright, so those revolutions were 21 revolutions, and each revolution covered 360 degree or 2 pi radian. So 21 into 2 pi becomes our radian. Alright, and if you want in terms of degree, it becomes 21 into 360 degree. Fine. So this is understood. Now let's talk about frequency. Frequency is 1 divided by time, and time, I told you, this is time period. That is, it starts from here and comes back over here. The time required for that is time period, capital T. Alright, okay, so frequency is 1 over T. So it's already given that it's 90 rpm, 90 rotations per minute, but we are interested in seconds, rps. So we just divide it by 60. So what we end up with is 3 by 2, that is 1.5 rotations per second. Now the situation is, what do we need to find? Calculate the time taken. Alright, now let's get into kinematic equations, right? Now the equations that we learned was V is equal to U plus AT. We'll convert this into rotation later on. First, as I told you, let's get into linear format, and then S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Alright, now let's try one by one. Now if I try, time is over here, here we don't have time. Alright, we don't have time here. Okay, now here T square is there, but for finding acceleration we again require time. Alright, which is not given, right? So this, we cannot take this. V minus ut, we cannot take this, because acceleration, for finding acceleration, I hope you know that V minus u upon t, that time is unknown. So we cannot get acceleration, over here. Alright, so we cannot use this equation. Alright, okay. So what we are left with is v square is equal to u square plus 2as. Alright, now let's convert that into angular. In case of angular, this would become omega square is equal to omega square is equal to omega 0 square. So initial angular velocity, final angular velocity, acceleration, angular acceleration, and theta. Alright, that's what is the conversion factor of this. So we don't require this. Done? Okay. Now what? Now you would say here also we have acceleration. Yes, we do have acceleration. So what can we do? What can we do by which we don't require that acceleration there, and instead of that we can have something else? So what I would do is I would convert this equation in form of angular acceleration. So angular acceleration would be equal to, I'll take it this side, so it would be, I took it this side, so it became minus omega 0 square, that is initial angular velocity. Then 2 and theta, I would take it below. Fine. Now you would think, where is t? So what I would do is I'll go to basic formula of angular acceleration, and basic formula of angular acceleration is what? Omega final angular velocity divide final angular velocity minus the initial angular velocity upon the time taken for that. Alright, and mind you, now what happens if both are angular acceleration? So I can jolly well equilibrate this with this, both being alpha, that is angular acceleration. So we got that. Now we just have got to substitute the values, because see, we know this, we know this, we know this, we know. So this is unknown, so we can find it out, right? So let me write it that way. So omega, it's all written over here. This is final, it stops, fan stops as final. So 0 minus omega 0 upon t, that's there. Then omega square again final, that is 0 minus omega 0 square. So why am I writing omega 0 square? We have got the value. Okay, let me write there, omega 0 square upon 2t. Alright, so let's substitute omega 0 also, right? So it will be, so it would be minus 3 pi upon t is equal to minus 3 pi square upon 2 into theta is also known there as 42 pi into 42 pi. Alright, so what do I do? So see, 1 pi of this goes and this goes, and 1 pi from here goes and here goes. I hope you understood. Like for example, if I take this pi down, it becomes pi square and then it gets cancelled. Do you want me to do that way? Okay, I'll do that way also. So it is 42 pi, and this was 3 pi, right? 3 pi square. So and here also we had 3 pi. So it becomes minus 3 upon t is equal to I'll make it 9. Yes, pi I took it here, right? So this goes, alright. So we have got 9 over here. Now minus also goes. Then 3 is a 9. 3, how much are 42? 3 1s are 2, 3 4s are 12. So it is 28. Alright, 28. Therefore, t is equal to, I'll take t there, 2 into 14, I'll take it there, so it becomes 28 seconds. Alright, so this is your answer. Alright.